Okay, so welcome back, and let's do a couple of examples. So in this case here, we've got these two sequences, and let's see if we can write an explicit formula for each one. Okay, so let's look at the first one here. So the first thing I notice is it's alternating signs, okay? So we've got negative, positive, and the first term, the first, third, and fifth term, so the odd terms are negative, okay? So if this is term 1, 2, 3, 4, 5, well, right away I can see that we're going to have a negative 1, and it's going to be raised to the nth power, and that's going to take care of the signs, right? So if n is 1, it's negative. If n is 2, it's positive. So if n is odd, it's negative. If n is even, it's positive. Okay, so that'll correspond to the even and odd terms. Okay, now next, look at the numerators here and look at the denominators. So a couple of things you may notice. So this one here goes 1, 2, and then the 2 goes here in the next term, 2, 3, and then the 3's here, and it goes 3, 4, and then the 4 goes here, 4, 5. So you see this kind of pattern going on. But also look at the numerators. The numerators start at 1 and go up by 1. The denominators start at 2 and go up by 1. Okay? So now the first term, n equals 1, right? Second term, n equals 2. Third term, n equals 3. So the top numbers follow n. Okay? So we'll have, let's say, on top, let's just put n, right? So if n is 1, we have 1. If n is 2, we have 2. So that takes care of the top. What about the bottom? Well, the bottom is 1 more than the top, right? That's the other thing. The bottom is 1 more than the top, okay? So we could do n plus 1, okay? Now, I believe that will take care of it. So this is the example. This formula will cover the entire infinite series, okay? Now, granted, sometimes you'll see it written like this. Okay, but again, they're the same. They're the same, okay? So that's it. So what about B? Now, let's look at B here. And again, let's look at what's going on. So again, I'm going to look at the numerators first. So what's going on with the numerators? We're going 3, 9, 27, 81, 243. Well, right away you suspect 3, 9, and 27, that these are powers of 3. And again, if you take 3 times 27, you'll get 81. And then 3 times 81 is 243. So yes, and again, so if it keeps going this way, then the top is going to be powers of 3. So this is 3 to the 1, 3 to the 2, so it follows n. So again, if this is a sub 1 and a sub 2, so it follows n, right? So this is going to be, so the top is going to be, what? It's going to be 3 to the power of n, right? Now, what about the bottom numbers now? Bottom numbers are 4, 7, 10, 13, and 16. So what's going on here? Well, it doesn't look like they're growing exponentially, right? Doesn't seem like they're growing like the top. So let's take some differences. So 7 minus 4 is 3. 10 minus 7 is 3. 13 minus 10 is 3, 16 minus 13 is 3. So it looks like it's an arithmetic sequence in the denominator. So how would we represent this? Well, we can represent this as 4, right? So 4 plus some multiple of 3, right? Or yeah, multiple of 3. Now in this case here, it's going to be, oh, actually, you know what? Let's do it this way. So there's a 3 in here, right? There's a 4. If we subtract 3 from this, we get 1. So we could actually rewrite this as 1 plus 3 times n. And so if we have n is equal to 1, we get 4, right? If we have n equal to 2, we get 7. And if n equals 3, we get 10, and so on. So this will give us the bottom number for each value of n. So this would be, if we just drop the parentheses, this is going to be 3 to the nth power, 1 plus 3n. And so that would be, or 3n plus 1. We could write it, this is probably more commonly, we could write it as 3n plus 1. Okay? And so now this is the explicit formula for this sequence. Okay, let's do one more. Okay, what about this sequence? Let's see if we can figure this one out. Let's say we have the sequence 1/5, -1/7, oops, 1/9, -1/11. Okay, let's say we have this sequence of numbers. And so again, notice that we have alternating signs. Now, if this is for n, 1, 2, 3, 4, and we have a sub n, right? So we have a sub 1, a sub 2, a sub 3, a sub 4. So what's going on here? Well, notice that the negative sign is on every even n. So immediately a sub n, how are we going to write that? Well, we're going to write that with what? -1. So we got to have a -1 in there because there's alternating signs. But because now it's on the even ones, we're going to have this be what? Let's do n plus 1. That'll work. So when n is 1, it's positive, and when n is 2, it's negative. So I'm just going to change, so I'm going to use n plus 1 for the power. Okay, so that'll take care of the alternating signs. Now the thing is the ones are constant and it's only 1, right? So again, in this case here, it's either going to be +1 or -1 on top, if you want to look at it that way. So this will take care of the numerator. In fact, let's do this. If we put this as -1 to the n plus 1, that takes care of the numerator. Now the denominator, what's going on with the denominator? Well, it starts with 5 and it's going up by 2. So I'm going to write this one as, well, there's a couple of ways we could do this. We could write this as If I subtract 2 from this, I get 3. So I can write this as 3 plus 2n. That will work. Because when n is 1, I get 5. When n is 2, I get 7. When n is 3, I get 9, and so on. So this would be the explicit formula for a sub n in this sequence. Okay? So again, make sure you practice doing these. Have a great day.